Moving into section 2, we're going to cover the boot process. So first we're going to cover the legacy version of how a computer would boot up. And essentially, as the name kind of suggests, we're booting up, we're powering on. So these are the sequence of events that happen when you first power on your computer. And legacy computers will use the BIOS firmware to interact and manage the boot process. Now, BIOS, this is, well, it stands for Basic Input and Output System, and it's a program that's going to run on your microprocessor, on your computer, and it's going to be used to start the computer system after it's been powered on. Something needs to kick off the computer to say, hey, we're waking up, and pretty much wake up the operating system so that everything can get loaded and you can start interacting with your computer. If you've ever seen pressing like F2 a bunch of times as your computer is waking up or booting up, and you get into the BIOS menu or a menu that you can change settings for your operating system on, it's because you're interrupting the process here and you're going to enter the BIOS utility and menu to be able to make changes to your computer's settings. So at a high level, these are some of the steps that happen. Your computer, your CPU is going to awaken, your BIOS code is going to be loaded into memory, and then it is going to execute. And the main objective is to locate the operating system. If it cannot locate an operating system, nothing will happen. You'll probably get an error message saying operating system can't be found, and your computer will not be able to function. Couple of different terminologies here. We have a warm boot. This is when the operating system is restarted without interruption, without power interruption. And a cold boot, this is initially it's powered on, kicks off the post, which is power on self-test, to check the hardware components. And just be familiar with what a warm boot is and what a cold boot is, just terminology to be familiar with, but would you be asked that on an exam? I don't think so. And maybe you've heard of the beep codes for errors. If your computer's ever given you 5 beeps and then you can Google, hey, my computer beeped at me 5 times when it was booting up. Well, there's beep codes assigned for errors based on your operating system and your hardware components for the computer that you bought. And you can actually look up the beep codes to tell you what's wrong with the computer's function during the boot process. And remember, this is for legacy only. Diving into this just a little bit deeper, we need to cover the master boot record. So the MBR, this is created when the hard disk is first partitioned, and it resides at the first physical sector of the drive. So that's going to be sector 0. It's going to hold the instructions for how to continue the boot process, and it's 512 bytes long. Reviewing the steps, we have the PC is turned on, the BIOS initiates the hardware, so BIOS is booting up. The BIOS is then going to call on the MBR for the code that's in there, and remember, it's at the start of the disk, so sector 0, and then when it has that, the MBR will load that code that's contained within it from the boot sector of the active partition, and that will kick off the active partition and load your bootloader. And this is the boot sector. It's going to load and run the bootloader from its file system. So basically, there are 4 main steps that you should be aware of. I'm not sure if this would actually show up on an exam because it's very legacy type focused, but just in case it is, we're going to make this Sailor proof and have an acronym for it. So the first step was BIOS. The second step was the MBR is going to find that first active partition and load the second stage bootloader. And then stage 3, we have boot process. It's going to load the kernel, and then at the end, the OS kernel is going to be loaded into memory, and the CPU is switched into protected mode. So if we take just the first letters here and make a fun acronym for it, you can make your own, but we're going to go with Big Mac, Burger King. Nice friendly rivalry here between McDonald's and Burger King to help you remember the 4-step process for the legacy boot up process. Big Mac, Burger King. Now let's talk about the modern way to boot up a computer. So I thought this image was pretty good, pretty funny. The old school boot process for the legacy that we just covered, our 4 steps are essentially here: Big Mac, Burger King, and then boom, our operating system is there. Now we're going to go into the new boot process, which we're comparing BIOS in the legacy, so right here, the old school boot, with the new modern way of how computers boot up with the UEFI. The UEFI stands for the Unified Extensible Firmware Interface, and it's pretty much replacing BIOS at the firmware level. It still can support the master boot record and the GUID partition table, which is the globally unique identifier partition table. We're going to call that GPT for short, as that's the second process. But if this were MBR, it would also support it. But now we're also introducing, instead of the MBR, we can also switch over to the GPT EFI bootloader. And the main difference is moving into a more modern approach to how computers boot up. It's more secure in the checks that it performs to make sure the verification process is more thorough. Each operating system, though, nowadays, it's going to have its own bootloader, its own partition, its own files that launch, and could be different depending on the operating system. And as technology continues to improve, more companies are going to have their own bootloader and advance how they want their operating systems to function and boot up. But the only thing that's different here is pretty much BIOS versus UEFI, and then the GPT is introduced, and at the end, we still have our operating system being located, and the computer will start up.